Hi, this is Unit 3, the start of Unit 3 actually, and it's on liquids and solids. If you're following the order of the units in the channel, then we would have just gotten done with gases, and now this is a natural extension of that unit. You see here, these are called phase diagrams, and you can change one phase into another. On the left we have water, on the right we have carbon. You can see that if we hold the temperature steady and raise the pressure, we could actually make graphite into diamond. But that will be in a much later video. Today I want to talk about surface tension and viscosity, the first two properties of liquids that we will discuss. Okay, before I talk about those two properties, let me just put a little schematic here that we can change gases into liquids and solids by changing what we could either lower the temperature or raise the pressure. The first property I want to discuss is surface tension. Okay, we'll talk about properties in the first couple of videos, and namely properties of liquids first, and we have here surface tension. If we take a look at maybe a drop of water, or can we put a drop of water on the table? That water is not going to spread out all the way to the edges, okay, into a very thin layer. Instead, it's going to form beads of water droplets. And there's an inward pressure or inward force of the molecules of water at the surface that helps maintain the shape. So let me draw a couple of water molecules at the surface and a couple water molecules underneath. And like I said, there's interaction between the water molecules. So yeah, we'll need to review our intermolecular forces. But the fact of the matter is the attraction between these water molecules at the surface are a bit stronger to counterbalance the pull inward because there is no pull upward. So for the molecules at the surface, there's an inward pull. Due to intermolecular forces. We know that as IMF, and the main one is hydrogen bonding for water. Okay. What happens here is you form an elastic film. And you've seen that in action with those pictures of those water bugs standing on the surface, or you could even do this at home. You could balance a needle on top of a cup of water. That's not because of buoyancy, that's because of this surface tension and this elastic film that's keeping the needle in place. I never told you the definition of surface tension. Let me do that. It's a long definition. It's the amount of energy needed to stretch or increase a surface of a liquid. Surface of a liquid by a unit area. Okay, so what are the units? I'm not 100% sure, but I think at 25 degrees, the surface tension of water equals 0.0728, and look at the units. We need energy. Pretty simple. Energy per meter squared. Again, this is the surface tension. Are you going to have to do any calculations of surface tension? Most likely not, but it's a good idea to have a quantitative feeling for these properties. Okay. But we see this quantitatively all the time. In the lab, you know that if you measure out water in a graduated cylinder, what have you been told? You've been told to measure from the bottom of what's called the meniscus. So here we have a graduate cylinder with its markings, and when you add water to it, you have this curving concave, right? And you were told to put your eye right here, looking at the bottom of meniscus. So you don't want to be at an angle, your eyesight. You want to have it perfectly horizontal at the meniscus. So yeah, a lot of people bend down to look at the graduate cylinder horizontally. Now, this is not an optical illusion. It's not a trick of the eye. The water molecules are actually crawling up the sides, and water, what's called, adheres to the wall. I'll give you the definition for adhesion in just a bit, but the verb is adheres to wall and pulls water upward. Again, due to surface tension. That pulling up of water in a tube, whether it's a graduated cylinder or a very skinny capillary tube, that's called capillary action. It's not by vacuum, it's by this adhesion. So with water, adhesion is greater than cohesion. Oh man, my cat. Alright, let me give you a definition. Adhesion is the attraction of liquid molecules to a surface. In this case, the surface of the walls of the graduate cylinder. Cohesion is the attraction of liquid molecules to each other. Okay. We see the opposite. Let me give you one example where that curve is actually convex. You see the opposite with mercury. So mercury actually does this. So with mercury, cohesion is greater than adhesion. All right. Is that good? We might be going on to our next property, B, which is viscosity. Because viscosity also, it's unlikely that you'll have to do any calculations on viscosity, but it's still a very important property of liquids. You have viscosity, and number A, or letter A, surface tension. Equals the measure of a fluid's resistance to flow. Okay. It has a units, and those units are Newton. Remember Newton? Newton is a force times seconds. What's going on with the lighting? Let me just change this so it's not so bright. Okay, better. Per meter squared. Weird units. Don't worry about, again, doing any calculations. Understand the trends though. The lower viscosity means that you're making the liquid thinner. The lower viscosity, the easier fluid flows. And typically you do this by raising the temperature. For instance, if you have maple syrup for your pancakes, taking them right out of the refrigerator, it's kind of, it doesn't flow very easily. It's kind of thick. But if you warm it up, it becomes thinner and has a lower viscosity and flows easier. So you're making the liquid thinner. Well, let me give you a couple of quantitative data. Water. So water has a viscosity of 1.01 times 10 to the minus 3 Newton dot second meter squared. I think we have some things in the house that has a lower viscosity. Paint thinner. Literally, it's thinner. Acetone. Acetone is nail polish remover. So where do I want to put this? Let's put it underneath. It's thinner. You would expect it to have a lower viscosity. 3.16 times 10 to the minus 4. So that is lower. And then higher, we could use syrup, but I have the number for blood. Fairly viscous. 4.00 times 10 to the minus 3. Okay. Actually, that went pretty fast. Those are the first two properties of liquids that I want to talk about, surface tension and viscosity. The next property is a little bit more calculations heavy, which is going to be vapor pressure. So I'll see you in that video.